Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called longest palindromic substring. So palindrome is a string that if you reverse that string, that we will get the same result. That's called palindrome. And here we need to find the longest palindromic substring. So if we see this example BABAD, then BAB is one palindrome and another palindrome is ABA. So the both are the length of 3, right? So if they both are length of 3, we can return any one of them. So yeah, let's try to understand the same thing here, right? So this is the example they have been given, BABAD, right? BABAD. So we will start from here and then we will just do the scan for each and every character, right? And if we do the scan of each and every character, we need to basically make sure that B is making the palindrome with the A, and then B is making the palindrome with B as well, right? So this B I will put and will so there will be like probably one for loop that will scan this linearly, and only one for loop will not be sufficient, and the reason is that because I need to make the combinations for all the strings, right? So I will have essentially two for loop. So B with each and every character, then similarly A with each and every character, and the similarly B with each and every character, and then basically in these two for loops I still have some helper method that will determine, okay, if it is palindrome or not, right? So that palindrome will return me true or false, and based on that I will just calculate the maximum length, and then I will return, okay, this is my longest palindrome, right? So this will be the brute force approach, and the time complexity for this one will be like n to the power cube, right? And the reason of this two for loop, that will take n square complexity, and this palindrome helper method itself will take another linear complexity, so that's why it will be n cube. So we will not be focusing too much to the NQ because that might be straightforward. That's little lengthy as well. So let's try to focus on the optimized solution. And the optimized solution, basically, if we have to reduce this to the n square complexity, then there might be the multiple ways like using dynamic programming, recursion, or whatever, right? So but here the convenient approach I would like to share that I found more convenient is the extension, like, right? So extension is nothing but if we just get every character by character, and we will stretch that from that character itself, then basically we can figure it out if it is palindrome or not. If it is palindrome, then we just record those indexes, lowest index and highest index, and then we can just make a decision, okay, this is the longest palindrome, right? So let me little bit explain that as well. So let's say BABAD, right? So if it is, this is the string, and let's start from B, and B will see that there is nothing because this is zero index, so we can see this is not I mean, this does not qualify the palindrome in with A, right? I mean, independently B is palindrome itself, but if I have to check with the neighbor, then it does not qualify, so it still length will be 1 itself. Then if I start from, if I pass the index 1 here, and that's where the extend approach will be come into the picture that I was explaining earlier, right? So what it will do, it will just go here and it will go here as well. So for the one index, it will check the zero index and it will check the second index as well, and if they are equal, then this pair I will just record this zero index and third index as well. And in fact I can just record the length as well, 0 and the 3 length. So my output will be the substring of 0 and 0 plus 3, right? So 0 and 0 plus 3, so this will be my output. So it will be BAB. Similarly, I will do the same thing for B. I will just pass the second index. Sorry, it was second, it's not third, right? So 3 is the length. So this is length, this is not the index. Don't get confused with the length and index. So 3 is the length. We will be keeping track of the length, so that because substring method, what it does when we use any substring method, and if I'm using 3, then it will be just returning me 0, 1, 2. It will be just emitting the last characters that I'm using the substring. So this is the property of the substring itself. Okay, so let's see if I'm passing the text to itself, then it will, what it will do, it will decrement 1, so it will be 1 will be there, and this will be 3, right? Third index. So what it will be checking, first and third index, and they are same, so it will be recording this as well. So first index and then 1 plus this length is also basically 3, and the length we can calculate like simply what we can do, we can just simply this 3 minus 1 plus 1, so 3 minus 1 is 2 and plus 1 is 3, so this is also length is 3, right? So 1 is a start index and then this end index is 4, so 1 to 4, right? So 0 1 2 3 and then 4. So 4 itself is, as I mentioned, that substring ignores the last index, so it will still be returning ABA, right? Similarly 0 to 3 it will be returning BAB. So this was just all the storytelling that I was doing, but once we will write some placeholder, then I think it will be more clear. But here I still want to mention two cases that we need to handle with this approach, and that two cases are, if let's say if my string length is 2, so this is the even length, right? And if I start from 0 itself, then basically I need to pass the end index itself, that is 0 and 1, and so that I can easily compare, right? And if my string length is odd, right, if my string length is odd and if I'm passing this 0, right, it's fine because it's first length. And if I'm passing 1, and even if I'm passing the start and end both are 1, then it should be fine because it will be just going anyways, it will be decrementing to find the neighbor, start neighbor and next neighbor itself by incrementing. So by decrementing and by incrementing, it will find both the neighbors, right? And it will keep doing till it find the same palindrome, right? So here the observation is basically I need to pass the different index in case of even length, and I need to pass the same index in case of odd length, right? So if these two cases we can consider, then I think this approach works good. So let's try to create some placeholders and then we can come back again as well. Right, so this is just the base case. If s equals to null, and let's say if length of s is itself is less than 2, right? So then in that case this will always be palindrome. So a single length will always be palindrome, null is itself is a valid palindrome, right? And we just need to scan this string, right? So let's go ahead and do that as well. I equals 0, I start length, I plus plus and we will create our this method call extend. Okay, and we will do the same thing for our even length string and odd length string as well, right? As we have seen in our whiteboard, right? So even length, if it is a, we need obviously we need to start and end different, and if it is even length, if it is odd length, then we really don't need to start and different, but because it will be already be going left and right, and it will be finding the previous and the next neighbors, and it will keep doing the same thing, right? So even if I'm passing one start and one end itself, it will be finding itself. But in this case I just need to explicitly pass 0 and 1 because this is the even length, right? So this is just an important point, and once we know this point, then I think it's super useful. So let's pass it here as, and then start is I and I plus 1, right? And this is s and then I and then I. This is odd length, right? So let's go ahead and create extend as well. This is just a extend, so I'm not going to return anything here. So let's do this string str. Let's say this is start, let's say this is end. Okay, so let's keep extending this str.char at, if it is start, if it is equals to str.char at, if it is end. So for the stretching, what we are doing, we are going left and we are going right. So let's decrement start, and let's increment n plus plus plus, right? Why we are doing this? Because from the middle, if you observe, we are just going, in case of odd length, we are going left and we are going right as well, right? And in fact, in case of odd length as well, let's say this is bb as well, right? So it's still from the start we will be still be trying to do the same thing, start minus minus and n plus plus. So the end will be here, so 1 2 3, it will be just doing the same thing, right? So we will be passing 0 1, and then the next iteration will be passing 1 to itself. So 1 will check for the 0, and then 2 will check with the 3 itself, right? And 2 will check with 1 as well. So that's how it will work for the odd even case. So this is even case and this is odd case, right? So that's how we will be handling. So this is one thing. And let's make sure that we are having the valid index as well. So if a start is because we are decrementing, so just make sure that it is greater than equal to 0, so that we don't get the index out of bounds exception, right? And the similar thing, because and we are incrementing, so just make sure that it is still inside the limit of string dot length, right? So having said that, I think we should be good here, right? So we did that. Now now we need to, as we discussed, we need to take 2 pointers, like start pointers and length pointers as well, right? So we have seen that length pointer will be useful, that if we will be just getting the longest substring. So let's do that. Let's take some lowest index and let's take the maximum length as well, because we want to find what is the maximum length. So after coming it here, we will just simply be returning the substring, right? So what we'll be doing here, I'm just placing placeholder here. So we'll be doing low comma low plus max length, right? So that's the idea. And so here what essentially what we can do, if our max length, if it is less than and if it is less than is our end minus start, right? And -1. So why we are doing -1 here? This is the important point to remember, that why -1, because if we observe this n plus plus, right? So n plus plus, it's going even if it's valid, it's we are still going inside this while loop, and we are incrementing this end, right? And then we are coming back to the while loop again, and then we are breaking. But till the time we already incremented the end one time, so we need to reduce that counter, right? Because it's already incremented that, right? That's one point. Another next follow-up question might be like, we are still doing the start minus minus as well, then why we are not incrementing? Because it's also decrementing, right? So the to answer that question is itself is, let's say if it is going to the -1, right? And we are doing end minus start, right? So let's say my end is 3 and start is -1. So 3 minus -1 would be 4, right? So I will be doing this -1. So I am still, even if it's minus, I am still incrementing, because it will be like this. So let's say my let me clear the board here. So let's say my length, maximum length, I found 3, and start I decremented, it would be -1, right? So what it will be there, 3 minus -1, right? So it would be 4. So I still, even if it is -1, I still incremented this y1, right? And with end also I will be incrementing, so I need to do the -1 in that case as well, right? So we don't need to increment by 1 if it is start minus minus, because we have been seen those examples, like and n plus plus, we definitely need to do the -1, because we have incremented it 1 times, right? And in case of start minus also, we will be definitely be needing the -1 itself, but not +1, right? So having said that, uh, if this is the case, then let's go ahead and calculate this thing. So n minus start -1, right? And our low will definitely be start plus plus in this case. And the reason of saying that, because start will be minus going 1 back. The similarly we are doing for end here, right? So end is incrementing one one extra step, right? And similarly start will also be decrementing one extra step, so that's why we need to increment y1. So if we are clear about that, then I think it's simpler, right? So start greater than 0. Let's quickly check for the compilation error as well, and let's see what's going on it here. So start and start plus 1 or start plus plus, it's the same thing. So okay, so this is working fine. Low and max length I just want to initialize because basically they are anyways global variable, and the reason they are global is basically because I'm using in these two methods, right? So I'm using in the helper method and using in the caller method itself. So I think it compiled successfully. Let's try to see if it is getting submitted. So looks like it's working fine itself here, right? And it's working the way that we discussed during our whiteboard, right? So start low plus max length, and we are just max length we are just calculating this way, and minus start minus 1, and max length is itself is basically, as we discussed earlier, this is not index wise, right? It's max length. So that's why, let's say if my index is 2 and max length, so 0 1 2, right? If index is still 2, then length will be 3, right? So if I'm passing the substring length 3, then it means it's considering 0 1 2, but it's not considering 3, because as I explained earlier, that substring always ignores the last character that I'm mentioning. So that's why this max length will work as expected. And from the time complexity and space complexity, why would it still be n square? And space complexity, here we are really not taking any other storage or anything, so in this case this will be the order of 1. Okay, so hopefully this is useful. Thanks a lot. Bye.